Good evening, Swati.
Good evening, ma'am. Ma'am, last class I was unable to attend since I had my English TA, ma'am.
Okay, but did you watch the recording?
Ma'am, you didn't send me the recording, ma'am.
No, I think I've told you in the class. No, it's the same playlist link. You just have to tap on that link which I've sent earlier. I've shared the link on mensuration. No, so you can check on June 19th. July 19th. Sorry, July 19th. I've shared a playlist link on mensuration. It's the same link. See, there is only one link for one chapter. So now we are doing mensuration. So when I make this playlist for mensuration and I add the first video in it or the first recording in it, from then on till we finish the chapter, all the videos will be or all the meeting recordings will be added in the same playlist. So the link is that one link only. You just have to use that link, one link for the whole chapter. All the meeting recordings of a particular chapter will be uploaded in the same, meaning will be added in the same playlist. So the link is the same. One link per chapter. I think that's easier to understand. There's only one link for a chapter. So for mensuration, I've already shared the link. You can find it. I've shared it on July 19th. So when you see, when I tap on that link, I can see all the videos in it. Okay, fine. So I had asked children, we had finished till here in the last class. I had asked children to complete this one and the next one, the 11th one. So we'll see the answer to the 10th and 11th one. So question number 10 says there is a pentagonal shaped park. Pentagonal meaning a five-sided polygon. A polygon with 5 sides. All the 5 sides may be equal, may not be equal. When we say pentagon, it's simply a polygon with 5 sides. When we say a regular pentagon, it means all the 5 sides are equal and all the 5 interior angles are also equal. Supposing it is given. Now here it is not given that it is a regular pentagon. So all the sides need not be equal. Now, if it is a regular pentagon, then all the sides will be equal. All the 5 sides will be equal. If it is a regular pentagon, all the 5 sides will be equal. That is, they'll have the same length. And all the 5 interior angles, 1, 2, 3, 4, and 5. All the 5 interior angles will also be equal if it is a regular pentagon. Like an equilateral triangle. An equilateral triangle is a regular triangle. Because in an equilateral triangle, all the 3 sides are equal and all the 3 angles are also equal. Each angle is equal to 60 degrees in an equilateral triangle. So we say an equilateral triangle is a regular triangle. Similarly, when we take a quadrilateral, a square is a regular quadrilateral. Quadrilateral is any polygon with 4 sides. A square is a regular quadrilateral. Regular quadrilateral. Quadrilateral is a polygon with 4 sides. And a square is a regular quadrilateral because a square is a quadrilateral, it has 4 sides. And it's a regular quadrilateral because all the 4 sides are equal and all the 4 angles are also equal. Each angle is equal to 90 degrees. A rectangle is not a regular quadrilateral because in a rectangle only opposite sides are equal. All the sides are not equal. So a square is a regular quadrilateral because all the sides are equal and all the angles are also equal. Similarly, here it's given it's a pentagonal shaped park. It is that you don't see the word regular here. So we cannot assume that all the sides are equal or the angles are equal. So it's simply a 5-sided polygon. A 5-sided polygon. Okay, so there is a pentagonal shaped park as shown in the figure. So this is the figure. For finding its area, Jyoti and Kavita divided it in two different ways. So Jyoti divides it like this and Kavita divides it like this. So see here, so now when we have to find areas of polygons more than 4 sides, because we have formula, otherwise we know the formula to find the area of a quadrilateral is half h into half d into h1 plus h2. So for certain plane figures, we have a formula to compute its area. Now, how do we find the area of this pentagon? So we have to join, we'll have to use line segments, divide this pentagon into triangles or, quadrilaterals, and then find the areas of the plane figures in it, add the areas to find the area of the pentagon. So how does Jyoti find the area of the pentagon? So she takes a line segment like this. You can see here. Jyoti takes a line segment like this. This way, Jyoti divides the pentagon into two
Equal halves, ma'am.
Okay, two equal halves. Two what? Two. What are the
Trapezium.
figures? Two trapeziums. So she divides it into two trapeziums. How does Kavita divide the pentagon?
Into a square and a triangle, ma'am.
Okay, into a square and because we can see it's a 15 meters all over. So it's a square and a triangle. All right. So for finding its area, Jyoti and Kavita divided it in two different ways. Find the area of the spark using both the ways. Yeah, please go through the answer. What's the formula to find the area of a trapezium?
Half into sum of the diagonals half into sum of the diagonals into the height.
Half into sum of the parallel sides into the distance between them. So see here, now in this trapezium, these are the parallel sides. This one and this one are the parallel sides. What is the length of BC? What is the length of BC?
15 meters.
15 meters. What is the length of AD?
30 meters.
30 meters. See, this is a trapezium. This one is a trapezium. This one is a trapezium. Which are the parallel sides? This one and this one. These are the parallel sides. And name the line segment, which is the distance between the parallel sides. Which is the line segment that represents the distance between the two parallel sides?
C and D.
CD, not C and D. C and D are 2 points. C is a point, D is a point. C and D are 2 points. CD is the line segment. CD is the line segment. Correct. So CD. So you can see here, just tell me if you understand this, Swati, half sum of the parallel sides. So BC plus AD, am I right?
Yes,
sum of the parallel sides, BC plus AD, correct? Into the distance between them. CD is the distance, but see, this is the distance between the parallel sides, this one. That's what is here, CD. CD is the distance between the parallel sides, correct?
Yes, ma'am.
So substitute the values. What will be the length of CD? What is CE? What's the length of CE?
15 meters, ma'am.
So what will be the length of CD?
Ma'am, it will be 15 divided by 2. That is
so you can
7.5.
Yeah, 7.5. You can take 7.5 or you can take 15 by 2, whatever is your convenience. So since CE is 15, CE is 15, CD will be 15 by 2, half of that. This is 15 by 2, DE is 15 by 2. Okay, so like that you can find the area of this trapezium. How do you find the area of this trapezium? Will the areas be the same?
Yes, ma'am. Since they divided into 2 equal trapeziums, the area will be same.
Area will be the same. So the area of the area of this trapezium, AFED, will be the same as this area. And now how will you find the area of the pentagon?
And we need to sum up the area of the 2 equal trapeziums.
Very good. So that will be the area of the pentagon. Now when okay, so what are the important things here? Which are the parallel sides? Name the parallel sides in this trapezium. Name the parallel sides.
Ma'am, the parallel sides are CB and AD, ma'am.
AD. BC and AD. You said CB, you're right. BC and AD are the parallel sides. BC and AD. Which is the distance between the two parallel sides?
CD, ma'am.
CD. What's the length of CD?
7.5 meter or 15 by 2 meter.
Okay. What's the length of BC?
BC is 15 meter.
And AD?
AD is 30 meter.
Very good. Now, she has divided the triangle like this, Kavita. Now, how will you find the area of the triangle? How will you find the area of the triangle? Now, answer this question. Yeah, correct. What is the length of this line segment?
15 meter.
15, because this is 15, because this is 15. See here, this one is 15, so this will also be 15. Opposite sides are equal. It's a rectangle. In fact, it's a square, because you can see 15 here, 15 here, 15 here. This is also 15 because opposite sides are equal. Now all the sides are 15, so it's a square. This one is a square because all the sides are equal. 15, 15, 15, 15. And this one is a rectangle. Sorry, this is a triangle. Half base is 15 into height. What is the height of the triangle? The base of the triangle is 15 meters. What's the height? What's the height of the triangle? What is the total height? What's the total height from here to here?
30 meter. 30 minus 15.
30 minus 15, 15 meters. Because the total height from here to here, this total height is 30 meters. It's marked outside here, from here to here. The total height is 30 meters. So from here to here, the total height is 30 meters. But we know from here to here is 15. That is this one is 15. This one is 15. So the remaining part will be 30 minus 15, which is 15. So when you in Kavita's case, there is a triangle and there is a square, correct?
Yes, ma'am.
How do you find the area of a square?
Ma'am, area of the square is 8 into.
And the area of the triangle is half base into height.
Yes, ma'am.
All right. Yeah, please finish it.
Can you show the question?
Yeah, sure. Sorry. Yeah, Nandana. Yes. Because there was only Swati when I started the class. You completed this, Nandana?
Yes,
Okay. Okay, Swati, since now Nandana has joined us, earlier it was only you, so I thought I'll allow you to write in the class. But actually, I told you, right? I had asked the children to complete this by this class. So can you take screenshots and complete it later?
Yes, ma'am.
Okay. Nandana, we just discussed. Yeah. Oh, sorry. Nandana, we just discussed the answer to this, so you can use the recording for the explanation.
Okay.
Yeah. It's the same link. I've already shared the link. I've already shared the playlist link for mensuration. Use the same link.
Next slide.
Yeah.
And 11th question answer.
Yes. Taken a screenshot? Yeah. Done, Swati? Yeah. Yeah, this one also take a screenshot. We'll just understand how the answer goes. The picture frame has outer dimensions. You can see it in the figure. Outer dimensions 24 centimeters by 28 centimeters and inner dimensions 16 centimeters by 20 centimeters. Find the area of each section of the frame if the width of each section is the same. The width of each section is the same. You'll have to find the area of each section of the frame. So this one is the frame. See, this is the photo. This whole thing is the picture frame. This whole thing is the picture frame. This whole thing. And this is where you can see the photo. And this is that frame part, that wooden part, or the, whatever material it is. That wooden part of, or whatever material the frame is made of, is this one. This entire thing is the picture frame. There's the picture here. The picture here. And this is the frame. This is the frame, that border. This is the frame. This is frame. This is the frame. So the frame basically, in the frame, basically, there are 4 pieces. 1, 2, 3, 4 pieces. Now you'll have to find the area of each section of the frame. So there are 4 sections. And it's very clear that the area of this section and this section will be the same. Area of section 1 and section 2 will be the same. Area of section 3 and section 4 will also be the same. 1 and 2 area will be the same. So you can find the area of section 1 and same will be the area of section 2. Then you can find the area of section 3 and same will be the area of section 4. Now, answer this question. Each piece of the frame is a, what is the shape? Is it trapezium? Is it trapezium? Each piece of the frame is a trapezium. Each one is a trapezium. Okay. Now, when we take up this trapezium, when we take up this trapezium, these are the parallel sides. These are the parallel sides. So what are the lengths of the parallel sides? What are the lengths of the parallel sides?
28 centimeter and 20 centimeter.
28 and 20 centimeters. This is the distance between them. This is the distance between them. How do we find the distance between them? How do we find the distance between them? See here. Now again, this one. Yeah, now see this side also. Now in this trapezium, on the opposite side, in this trapezium, these are the parallel sides. These are the parallel sides. So what is the length of the side? What's the length of the side?
20 centimeters.
20 centimeters. Yeah, what's the length of this side?
28 centimeters.
28 centimeters. And the distance between them is, the distance between the 2 parallel sides is this line segment. Now, this total length, see here, the total length from here to here. How much is it? What is this total length from here to here?
24 centimeters.
24. 24. How much is it from here to here?
16 centimeters.
16. What is 24 minus 16?
8, ma'am.
8. So 8 divided by 2. It'll be 4 here and 4 here. I'll tell you again. Yeah, so see here, we'll take up this line segment. The length of this line segment is 24 centimeters because here it's 24. So this length is also 24 centimeters. Now the length of this piece is 16 centimeters. So 24 minus 16 is 8. So 8 is to be shared equally between this piece and this piece. 8 centimeters is to be shared equally between this piece and this piece. So it will be 4 each. 4 each. So see here, it's 4 here and 4 here. Now total it, 4 plus 16, 20. 20 plus 4, 24. Is the total length. So for these two trapeziums, the distance between the parallel sides is 4 centimeters. For these two trapeziums, the distance between the parallel sides is 4 centimeters. In the same way, we have to find the distance between the parallel sides of these two trapeziums. See here, 1 minute. Now, for this trapezium. Children.
Ma'am, this trapezium length is 16 and the outer length is 24 centimeters.
Yeah. So in this piece, again, this is a trapezium. These are the parallel sides. This one measures 16. This one measures 24.
24.
Correct?
And the same as the other one.
Correct. For this trapezium also, these are the parallel sides. This is the trapezium. This is the trapezium. And these are the parallel sides. They measure 16 centimeters and 24 centimeters. So we have the length of the parallel sides. We need to find the distance between them. So this is the distance between the parallel. This is the distance between these two parallel sides. And this is the distance between these two parallel sides. Now, what is this total length, children? What is this total length?
28 centimeters.
28 centimeters. How much is it from here to here? From here to
16 centimeters.
20 centimeters. This full thing is 28. This full length is 28. Now, from here to here is 20. What is 28 minus 20?
8, ma'am.
8. 8 divided by 2. 4 here and 4 here. Yeah. So now you can add and see. 4 plus 20, 24, 24 plus 4, 28. So now for the trapeziums, you know the length of the parallel sides and the distance between them. Just put it in the formula and find. Please go through the working. Swati, please go through the working. See, this is the children, this is the figure given in the question. In this figure, you can see we have marked the regions 1, 2, you can see 3 and 4. This is in the solution. You have to mark this. Yeah. This is the picture given in the question. When you write the solution, you should draw the figure and mark these. And then you can say area of section 1, area of section 2, section 3, and section 4.
Instead of calculating for area, area of section 2, can we keep the area of section 2 as 80 centimeter?
Yeah, I have not found the area of section 2. You can see here. Directly I've written area of section 2 is 80 centimeters square. We don't have to find. Yeah. Similarly, I found only area of section 3. I calculated area of section 3. 4 is the same.
Yeah, ma'am.
Yeah, and we don't have to add everything because the question is find the area of each section of the frame. The frame has 4 sections. You should find the area of each section. So don't add all.
Then we can directly simplify 2 and 20.
Nandana, louder, you can?
Then we can simplify 2 and 20 and 2 and 16.
Ah, yeah, correct. Talking about the simplification, is it? 2 and 16, huh?
Yes, ma'am.
No, we cannot cancel 2 and 16.
And they are in a different
It's addition. You have to add 16 plus 24 is 40. You can cancel 2 ones or 2 twos are.
Okay, ma'am.
Here also, you cannot cancel 2 and 20. 2 ones are, you can cancel this 2 ones are, 2 twos are. You should add 20 and 28, 48. And into 2. Swati, can you take a screenshot and complete it later?
Yes, ma'am. I completed half of it.
Okay. All right. You have a screenshot, Swati?
Ma'am, I was taking it, ma'am. I was unable to. Yes, ma'am.
Okay. Okay, before we start this, now tell me, children, let's recall the formulae we have learned so far. Name this figure. Name this figure. Name this figure, children.
I'm a quadrilateral.
A quadrilateral. Now, supposing it's a quadrilateral. Okay, and I call it P, Q, R, S. Name the 4 sides of the quadrilateral. Name the 4 sides of this quadrilateral.
Shall I?
Yes.
And the 4 sides of the quadrilateral are PQ, QR, RS, and SP, ma'am.
And SP. How many diagonals does the quadrilateral have?
2 diagonals.
2 diagonals. Name the diagonals.
PR and QS.
PR and QS. Now, I want to connect one of the 2 diagonals. I don't want to connect both. Tell me which one, you tell me which one shall I connect? Okay, we'll connect PR. Okay, we'll connect PR. Okay. Now, if we connect PR, to find the area of the quadrilateral using the formula, half D into H1 plus H2. Now, we know the diagonal PR. So, half D, we know the diagonal PR. Okay, I'll give you some length. So, we know the length of the diagonal PR. I'll give you the length. Now, we need to have the values of H1 and H2. What are H1 and H2? They are the perpendiculars on this diagonal from the opposite vertices. They are the perpendiculars on this diagonal from the opposite vertices. Now see here, for this diagonal, this is one opposite vertex. This is the other opposite vertex. Now see here, this is a perpendicular. This is a perpendicular from the opposite vertex Q on the diagonal PR. And this one is the perpendicular from the opposite vertex S on the diagonal PR. These are H1 and H2. These are H1 and H2. D is the diagonal. We know that a quadrilateral has 2 diagonals. So you should know the length of any one of the 2 diagonals. Okay, to use the formula. Then, now you know the length of one diagonal. Next, you need to have the values of H1 and H2. H1 and H2 are the perpendiculars from the opposite vertices on the diagonal. So you can see here, both the perpendiculars fall on PR, on the diagonal PR. You can see that both the perpendiculars, they land on PR. They touch PR. So they are H1 and H2. So area of quadrilateral PQRS is equal to half D into H1 plus H2 square units. Yes or no, children?
Yes, ma'am. How will it change if we have QS as the diagonal?
Yeah, that's what I'm going to do next. So now let's take the same quadrilateral. Okay, P, Q, R, S. Now, instead of connecting the diagonal PR, let's connect the diagonal QS. Let's connect the diagonal QS. So that means we know the length of this diagonal. Now we need to have the perpendiculars from the opposite vertices on this diagonal. Which are the opposite vertices? P and R. They are the opposite vertices. P and R are the opposite vertices. So see here, from P, the perpendicular should land on the diagonal, and from R, a perpendicular should land on the diagonal, Can you see these two perpendiculars? They're landing on QS. Yes or no?
Yes, ma'am.
So anything can be H1. See, if this is H1, this is H2. There's nothing like this particular thing only should be H1. Nothing like that. There are 2 perpendiculars. Call one as H1, the other one as H2. So this is what it is. Half D into H1 plus H2. Half into length of the diagonal into the sum of the perpendiculars on that diagonal. Sum because we are adding H1 and H2. What are H1 and H2? The perpendiculars. The sum of the perpendiculars on that diagonal. Is it clear, children?
Yes, ma'am.
Yeah. Half D into H1 plus H2. Half into length of the diagonal. D is the length of the diagonal into H1 and H2 are the lengths of the perpendiculars on that diagonal. So add H1 plus H2 square units. This is what we have understood about finding the area of a quadrilateral. If you want to make a note of the diagrams, I'll just give you a minute's time. Please do it. All right, children. We'll see the next one. Rhombus. Rhombus. Next, we learned how to find the area of a rhombus. In the chapter Understanding Quadrilaterals, we'll see the different properties of quadrilaterals and special quadrilaterals like parallelograms, rhombus, rectangles, and squares. Yeah. Now, to find the area of a rhombus, okay, now if I call it ABCD. Supposing we know this altitude. Okay, so base is practically since all the sides are equal in a rhombus, since all the sides are equal, any side of the rhombus is taken as the base, and the altitude is the length. The height is the length of the altitude or the length of the perpendicular on that base. On that base, so it can be like this, or it can be like this. Can be this is the altitude. So here, like this is the altitude. This is the altitude from. So we've seen two ways of finding the area of a rhombus. Area of a rhombus. I call it ABCD. ABCD. Okay, and supposing we take this altitude. So this is height. This is the base. Base into height. Base into height. Area of rhombus. Area of rhombus. Rhombus ABCD is equal to base into height. If you know the value, if these values are given to you, that is the length of the base and the altitude, then you will have to use this formula, base into height. Base into height, square units. Square units. Base is the length of the side of the rhombus. All the sides are equal. So if you know the side of the rhombus, that is the base. The height also will be given to you. So then use this formula, base into height, square units. If the values of the base and height is not given, instead you're given the length of the diagonals. You're given the length of the diagonals. Okay, this diagonal is called D1, the other diagonal is called D2. Okay, D1 and D2, the length of the diagonals. See here, A, B, C, D. AC is one diagonal, BD is the other diagonal. So area of rhombus ABCD, area of rhombus ABCD is equal to half product of diagonals, half into product of diagonals. Product of diagonals, half into product of diagonals, square units, area, no, so square units. So half into AC, diagonal AC into the diagonal BD, product, multiply the diagonals, half into product of diagonals, AC into BD. So that's what we say, half D1, D2, half into D1 into D2, or simply half D1, D2, half D1, D2, square units. Half D1, D2, half into product of diagonals. This is what we have learned. This is how we find the area of a rhombus, given the base and height, or when we are given the length of the diagonals. Is it fine, children?
Yes, ma'am, understood.
Okay. Able to recall, Nandana? She's not there?
No.
Yes. Able to recall, Nandana?
Yes, ma'am.
Okay. Good evening, Harshita.
Ma'am, good evening, ma'am. Now only I came, ma'am. I had Hindi tuition, ma'am.
Oh, okay, okay. Hindi is your second language or third language at school?
Ma'am, I'm not sure, ma'am, but our Hindi is, ma'am.
Okay. Okay. You're not sure if it is the second or third language, is it?
Ma'am.
Okay, okay. Fine. What's the first chapter in your Hindi textbook?
No, I don't know, ma'am.
Okay. Okay, okay. Don't know. Don't say that you're a Hindi tuition teacher. You'll make her very unhappy. Okay,
Okay.
what is it you learned in Hindi tuition today?
Ma'am, she taught me some new meanings for the new lesson we wrote in class, ma'am.
So, okay, what is the name of that lesson?
Ma'am, I didn't make note of that, ma'am.
Okay. So you just joined the meeting. Your tuition bag will be lying beside you only, I think. Yes or no?
Yes, ma'am. It's right here, ma'am.
Yeah, I know. You just you must have put your bag just beside you. Open a Hindi textbook and tell me the name of the chapter you learned in the tuition.
And will you speak Hindi?
Swati?
And will you speak Hindi?
Yes.
Ma'am, it's Akiri Pata, ma'am.
What?
Ma'am, Akiri Pata.
Akiri Kata.
Yes, ma'am. Pata.
Yeah. Patta. Okay. Yeah. So what is Akiri? What's the meaning of the word Akiri?
No, I don't know, ma'am. Not sure. Ma'am, today only
What
we
is
started.
Patta? What's Patta? Okay. Akiri is last. Patta is leaf. Last leaf. Probably the tree shedding all its leaves.
Yes, ma'am.
Akiri Patta meaning the last leaf. Okay.
Ma'am, I don't know
Fine.
even a single word in Hindi, ma'am.
Oh, okay. No, that's because you're not learning this language at school, right?
Hindi is my third language, ma'am.
Then
I know to read the words, ma'am, but I don't know to write it, ma'am.
okay. Okay. We'll do Hindi.
Yes, ma'am.
Yeah. All right, children, fine. I'll catch Harshita with something else in the next class. All right, children. So
Yes,
see
ma'am.
here. Yeah. Okay. Give a name to these figures, children. Give a name to these figures. Trapezium. All are trapeziums. Why? Because you can see first it's they're quadrilaterals, and in the quadrilaterals you see that one pair of opposite sides is parallel. One pair of opposite sides is parallel. See here, this is a quadrilateral. If I draw something like this is a quadrilateral. This one is a quadrilateral because there are four sides. Now, when I mark like this, that means this pair of opposite sides is parallel. In a quadrilateral, when one pair of opposite sides is parallel, the quadrilateral is called a trapezium. It's a special name. It is a quadrilateral, not that it is not a quadrilateral, it's only a trapezium. No, it is a quadrilateral. And the special name is a trapezium. It's a trapezium. And now this is the distance between the parallel sides. This is the distance between the parallel sides. The perpendicular distance between the parallel sides. Now this is A, this is B, and this is H. So now what's the area of the trapezium? How do you find the area of the trapezium? Half sum of the parallel
sides into the distance between the parallel sides.
Very good. Half into sum of the parallel sides into the distance between the parallel sides. Area of the trapezium is equal to half into sum of the parallel sides, A plus B, into the distance between the parallel sides. The trapezium can also be like this. It can also be like this. It can also be like this. So here, these are the opposite, these are the parallel sides. This pair of opposite sides is parallel. So this is the distance. This is the distance between them. Or you can also mark this one. This is also the distance between them. So anything can be A, children. Okay, so this parallel side is A, this is B, and this is the distance between them, H. So half sum of the parallel sides, A plus B, half into sum of the parallel sides, A plus B, into the distance between the two parallel sides, H. square units. So this is the formula to find the area of a trapezium. So this is what we have learned in the last exercise 11.2. How to find the area of a quadrilateral, how to find the area of a rhombus and trapezium. Rectangle and square, you know. Rectangle and square, you know. Now, how do you find the perimeter of a? How do you find the perimeter of this trapezium? This is a trapezium ABCD. How will you find the perimeter of the trapezium ABCD?
Sum of the sides.
Correct. So perimeter is nothing but the length of the boundary of the closed figure. It's the length of the boundary of the closed figure. So it's AB plus BC plus CD plus DA. The sum of the length of the four sides. AB plus BC plus CD plus AD is the area of the trapezium. Sorry, perimeter of the trapezium. Okay, so now here in this exercise, we are going to learn about the area, the surface area of a cuboid and I think cylinder. Yeah, cylinder. All right. So in this exercise 11.3 from NCERT, we're going to see the solids cube, cuboid, and cylinder. Cube, cuboid, and cylinder. Now, children, you know how a cube looks like. How many flat surfaces does a cube have? How many flat surfaces does a cube have?
6 flat surfaces.
Six surfaces. A cube has 6 surfaces. Okay. Now, when you take a cubicle room, all right, a room is cubicle. Now, you are standing inside the room. The four walls of the room are the 4 surfaces. And then the remaining 2 surfaces are the ceiling and the floor, correct? When you're standing inside a cubicle room, which are the 6 surfaces? The 4 walls. You can touch now where we paint, where we distemper, the 4 walls. They're all area, they're all surfaces. When you paint the 4 walls, you're painting the 4 surfaces of the cube. And then the remaining 2 surfaces, the ceiling and the floor. Yes or no?
Yes, ma'am.
Similarly, if the room is a cuboidal room, again, the 4 walls are the 4 surfaces. Then the 5th surface, ceiling, 6th surface, floor, or anything. Floor is the 5th surface, the ceiling is the 6th surface. So the 6 surfaces, when you take a room, for example, a cubicle room or a cuboidal room, the 4 walls, the surfaces of the 4 walls, the surface of the ceiling and the floor. These are the 6 surfaces of a cubicle room as well as a cuboidal room. Yes or no, children?
Yes, ma'am.
Okay. So now when you have a cube with you, you can feel the 6 surfaces outside. You have a cube with you, you can touch, you can feel all the 6 surfaces. Again, when you have a cuboid with you, a textbook, your textbook, R.D. Sharma textbook, your NCERT maths textbook is a cuboid. It's a cuboid. You can touch all the 6 surfaces, the top, the bottom, and the four surfaces on the sides. Or your pencil box. Your pencil box is cuboidal. If you have a pencil pouch, that is not cuboidal. Your pencil pouch is not cuboidal. Pencil box. Okay. The magnetic pencil box. It's cuboidal. It's cuboidal. So there's a top surface, the bottom surface of the box, and the 4 surfaces on the sides. Front side, back side, left side, and right side. Now we are going to see the formula to find the volume. Let's first find the volume of a cube and the volume of a cuboid. How do we find the volume of a cube? In simple words, we'll see in detail in 9th standard. Now I'll just give you, a slight hint about how volume is found. Volume is area into height. Volume is area into height. Volume is area into height. Area into height meaning the area of the cross section into height. Now the cross section of a cube is a square and the cross section of a cuboid is a rectangle. The cross section of a cube is a square. The cross section of a cuboid is a rectangle. Now when we say area into height, area of the cross section, what is the area of a square? What is the area of the square? Side square or a square into what will be the height of the cube? That also will be a, no, because in a cube all the edges are equal. In a cube all the edges have the same length. So the volume of a cube is a cube cubic units. A cube cubic units. Let me write it neatly, 1 minute. Area of uniform cross section. Area of uniform cross section. I'll just write C as cross section into height. Into height. So uniform cross section is a square. So a square into the height is also a. Because in a cube, all the edges have the same length. So a square into a is a cube cubic units. Cubic units. Please write on this. Please write on this. Next is the cross section, sorry, curved surface area. Next is the curved surface area of a cube. Okay. When we say curved, there are two things, total surface area and curved surface area. So now let me say like this, let me give a name to all the 6 surfaces of a cube. Okay, so top surface, somebody's mic is enabled. Please disable your mic. Yeah, thank you. All right. Now, children, a cube. I'll just give a name to all the 6 surfaces. Top surface, bottom surface, front surface, back surface. Or you can just say top face, bottom face, front face, back face, right face and left face. Am I clear? Am I audible? Yeah, now tell me all the surfaces. Top face, then
And front face.
no, top and what is this? Below.
And bottom face.
Bottom face. Then
Side.
side faces are the right face. The face on the right side. Side faces. Yeah, they're the side faces. The face on the right and the face on the left. Side faces. Then
And the front face and the back face.
yeah, front face. Front face and the back face. These are the 6 faces. Now, when we say curved surface area, it is not including the top and the bottom face. Only the vertical faces. The 4 vertical faces. The 4 vertical faces. Only the 4 vertical faces. Now see. Now, this cube, Now, this is the top face. This one is the top face. This is the top face. This is the bottom face. This is the bottom face. Now, these are standing. No, these faces are standing. Can you see? These faces. These faces are vertical. These are horizontal. 2 faces. The 2 faces are horizontal. You can see this face. It's sleeping. It's horizontal. This face and this face. The top face and the bottom face, they are horizontal. Can you see it, children? Am I right? Am I right?
Yes.
Yeah, but the front face, the back face, and the 2 side faces, they're vertical. They're standing up. The front face, the back face, and the 2 side faces, they're vertical. They're standing up. But the top face and the bottom face, they're horizontal. They're like in sleeping position. They're horizontal. Only if I'm clear here, I can continue. Saying, let me repeat, Q, it's the same for a cuboid also. The same explanation for a cuboid also. In this cube, this is the top face. It is horizontal. It's sleeping, the top face. This is the bottom face. The bottom face is also horizontal. It's horizontal like this. There are four faces which are vertical. See here, this face, left face, this right face, it's vertical. The front face, this is the front face, that's vertical. The back face is also vertical. Four faces are vertical. Two faces are horizontal. Curved surface area is the area of the four vertical faces. Now, when you take a room, the area of the four walls is the curved surface area. Because the walls are vertical, they're standing. But the ceiling and the floor, they're horizontal. The ceiling and floor, they are horizontal faces, while the four walls are vertical faces. Surface, face, all the same. So curved surface area is the area of all the vertical faces. All meaning four is the area of the four vertical faces. So curved surface area is the area of the vertical faces. Area of the vertical face. This is just for us to understand area of the vertical faces. So how many vertical faces? Four vertical area of the four vertical faces. Now, in the case of a cube, what is the area of each vertical face? Each face is a square. So the front face A square, back face A square, the side faces A square and A square. So 4A square square units is the curved surface area, is the formula to find the curved surface area of a cube. Curved surface area, not volume, area. There are four faces. Curved surface area is made up of four faces. The four vertical faces. What is the area of each face? Each face is a square. A square, A square, A square, A square. 4A square units. Please write down.
I have a doubt, ma'am.
Yeah.
If they give a cube and they ask to find the volume and the curved surface area, will the answer be same in both the cases?
If they ask, if given a cube, can they?
Ma'am, if they give a cube and they ask to find the volume and the CSA of that particular cube, the answer will not be the same.
No. They need not be the same.
Yes, ma'am.
Yeah. Yeah, children. Write on this.
For me, after CSA equals nothing is visible.
Sorry? The answer?
Curved surface area I have written, no, ma'am. After that, visible.
Curved surface area is equal to area of the four vertical faces. Swati, what's your question?
No, ma'am. Like you have written CSA on the screen, no, ma'am. CSA equal to and then nothing is visible.
I've written no, CSA is equal to area of the four vertical faces.
It's not visible for me, ma'am. Only the volume is visible.
Oh, darling, leave and join again, ma. It's there. I've written everything.
Yes, ma'am. Now only it's visible.
Oh, okay. I wrote it some time back. Yeah. Done, children?
Done, ma'am.
All right. The others, Harini, not Harini, Harshita and Nandana. Harshita and Nandana were also in Kamlaniketan earlier, is it?
Yes, ma'am.
Oh, Harshita also studied. So you've all studied together, huh? Swati, Harshita, and Nandana.
Yes, ma'am.
Harshita was she studied with me in 5th standard.
Okay. So you all know each other then because you were once in the same school. Okay.
Yes,
Okay.
ma'am. I do know Swati, ma'am.
When did you move to Kaveri Global, Harshita?
Ma'am, this year, ma'am.
Oh, okay. And you, Nandana?
Me too this year. We both are same.
Okay, okay, okay. Fine, fine. Yeah, children. Finished writing this?
Yes, ma'am.
All right.
Yes, ma'am. Done, ma'am.
Okay. Now, again, the same thing, cube. We'll find the total surface area. Total surface area of the cube. Total surface area is the area of the 4 vertical faces plus the area of the 2 horizontal faces. Is this clear? Total surface area, all the area. So the area of the 4 vertical faces is a squared plus a squared plus a squared plus a squared. And these 2 horizontal faces, a squared plus a squared, because top and bottom, top a square, bottom a square. So 6a square units. 6a square units. Now you don't have to write so much. You should just remember that the total surface area of a cube is 6a square unit. That's all. Don't write all this. This is just to understand. Now what you have to remember is total surface area of a cube is equal to 6a square units. That's all. Finish writing?
No, ma'am.
Okay.
Can you tell again the full form of PCS?
Nandana?
Can you tell the full form of PCS? I left the meeting and came because still the
TSA, yeah?
yes, ma'am, PS.
Total surface area. Total surface area. Curved surface area. It's also called the lateral surface area. Curved surface area is also called the lateral. Curved surface area. Surface area is also called the lateral surface area. Surface area. Lateral surface area. LSA, CSA, both are the same. LSA, CSA, both are the same. Now I have a question for you. Finish writing, children? Can I clear the slide?
Yes, ma'am, completed.
Yes, ma'am. Ma'am, can I leave and join? I have some internet issue, ma'am.
Yeah, sure. Done, children?
Yes, ma'am.
Okay. So what have we understood? Volume of a cube. Volume of a cube is equal to a cube cubic units. curved surface area of a cube is equal to 4a square square units. And the total surface area of a cube is 6a square square units. Now, you have a cube. Okay, you have a cubical box. You have, okay, let's take the example of the overhead tank. Okay, the overhead tank is cubical. It does not have a lid. It's an open tank. The overhead tank is an open tank. It's a cubical tank. There is the floor. The tank has the floor and it has the 4 walls. It does not have the lid. It's open at the top. What is the surface area or what is the total surface area of this cubical tank? What is the total surface area?
And 60 squared and the particular square unit.
6a square. Huh? Okay, think.
Ma'am, are you saying that there is no lid above the overhead tank?
Yeah, there is no lid. It's open. The tank is open.
Ma'am, so
It's
we need to find the length of the lid, no, ma'am, to close it. Then after that, we need to find the total area.
It's okay. No, it's not like that. Have you seen these carton boxes? Or these gift boxes, you know, small gift boxes. Gift boxes. Okay, just imagine a box like that without the lid. Without the lid, it's an open box. It's a cubical box, a gift box. It's a cubical box without the lid. Meaning there is a lid, but you have kept the lid aside. Leave the lid. The cubicle box has a lid, but leave the lid. The lid is aside. Leave the lid aside. Now this cubicle box with you, supposing you have to paint it outside, all over outside. How many faces will you paint?
5 faces.
5 faces, and that is only the surface area. We need not find the area of some face which is not there. You should find the area of something which is present, not absent. So how many surfaces are present? The 4 side faces, that is the 2 side faces, the front and the back face, and the bottom face. The top face is not there. Then how can we find the area of something which is not there? The top face is not there. This top face, this is open. It's open here. So there is the 2 side faces, the front face and the back face is there, and the bottom face is also there. So only 5 faces are there. And if you have to paint the box, supposing you'll have to paint the box outside, you will paint 1, 2, 3, 4, 5. That is 4 and the bottom 5 faces. So the area, so the question will be find the total surface area. So when they say total surface area, doesn't mean that you should use 6a square. No. That the word total does not always mean, total means what? Total means find the total area of whatever is present. So in our example, the total surface area is the area of only 5 faces.
That means the equation will change into 5a square.
Yeah, 5a square. 5a square, because a square only 5 times, 5a square. Okay. Find the area of the surfaces which are present. So only 5 surfaces are there. The 2 side faces, the front face, back face, and the bottom face. The top face is not there, so don't find its area. The total surface area is 5a square units. Now just imagine it's a hollow cubical box. That is, the top is empty, the bottom is, meaning the top is open, the bottom is also open. It's not a cubical box then. If it's a box, it has to be closed. At least the bottom should be closed. So I cannot call this a cubical box. So something cubical is open at the top and bottom. Then what is the total surface area? Then what is the total surface area?
4a square.
4a square. That's all. So we should not get confused with the word total. Total means The total surface area of that particular object. So if something which is cubical is open at the top and bottom, if something which is cubical, it's open at the top and bottom, the total surface area will be the area of only the four faces, because top face is not there, bottom face is not there. So there is no area there at all. So supposing you'll have to paint, you'll only paint the four faces, the two side faces, front and back face. Top face, no. Bottom face, no. So 4a square. So whenever they say total surface area, don't blindly use the formula 6a square. You should analyze how many surfaces that cube has. If that cube has all the six faces, then it is 6a square. But if that cube is open at the top, then it's only 5a square. Supposing the top and bottom is open, then only 4a square. Is it clear, children? Okay,
Yes,
so that's about, yeah, so that's about a cube. Now cuboid. Cuboid volume. Same thing. It's the area of the uniform cross section. Area of uniform cross section. Area of uniform cross section. Cross section. Into height. Into height. This is how we find volume. Area into height is volume. Area into height is volume. Now the cross section of a cuboid is a rectangle. The cross section is a rectangle. So what's the area of a rectangle? L into B into H. So that is LBH or L into B into H, cubic units, cubic units, cubic units, or simply LBH. L into B into H or simply LBH, cubic units. Volume is area into height. Area of the uniform cross section into height. The cross section is a rectangle, and rectangle's area is L into B. L into B into H. LBH cubic units. Please write down this.
Done, ma'am.
Yeah. Yeah, children. Next, curved surface area of a cuboid. CSA of a cuboid. Cuboid, same heading, CSA, curved surface area. Now, let me take the help of this figure. Let me take the help of this figure. So now this is a cuboid, this is an aquarium. 1 second, children, just a second. Yeah, thank you, children. So you can see the aquarium here, which is cuboidal. It's cuboidal. Oh my God. I'm so bad. 1 minute. I just wanted to be visible. That's why I'm trying to. Okay, fine. So now Children, this is the length of the cuboid, correct?
Yes,
Please
ma'am.
answer. Okay, this is the breadth. This one is the breadth of the cuboid, yes? This one,
Yes,
this is
ma'am.
the breadth. This is the breadth. Okay, and this is the height of the cuboid. This is the height of the cuboid, correct?
Yeah, ma'am.
Yeah. Now, okay, how many edges does a cuboid have? Both a cube and a cuboid. How many edges? How many
12
edges?
edges.
12 edges. Yeah, 12 edges. You can see 12 edges. That is, there will be 4 edges along the length. Now, children, I can just give the formula and start working. But to answer any question based on cuboids, you need to understand this. Otherwise, we can just simply take the formula and start working. But if you have to answer any question from cuboids, you need to know all this. So please listen. I'm not wasting your time. Please listen to this. There are 4 edges along the length. See here. See here. This is one edge. This is one edge along the length. This is L. This is also L. This is also L. And this is also L. These are the 4 edges along the length. All these 4 line segments are the length of the cuboid. That is, they'll have the same value as the length of the cuboid. Next, breadth. There are 4 edges along the breadth. See here. This is breadth. The on top here, this is also breadth. On top here, this is breadth. Here also, this is also breadth. This one is breadth. That is, the value will be equal to the breadth. This one also, the value is equal to the breadth. This one, the value is equal to the breadth. This one, the value is equal to the breadth. And now height. There are 4 edges along the height. See here, this is height. This is height. This is height. And this is also height. So both a cube and a cuboid have 12 edges. 4 edges, a cuboid has 4 edges along the length, 4 edges along the breadth, and 4 edges along the height. In a cube, all the 12 edges have the same length, A units. In a cube, since all the 12 edges are equal, the length of all the edge is A units. But in a cuboid, all the 12 edges don't have the same length. So there are 4 edges along the length, 4 edges along the breadth, and 4 edges along the height. 4 plus 4 plus 4, 12 edges. Now, do you all understand the edges which represent length, breadth, and height? Is it clear?
Yes, ma'am.
Okay. Now, answer this question. How many flat surfaces does a cuboid have? Or how many faces does a cuboid have?
6 faces, ma'am.
6 faces. Let us now find the area of each face. Now in a cube, you know, since each face is a square, all the faces have area A square. A square everywhere, it's A square. But in a cuboid, it's not like that. Now we are going to find the area of the 6 faces separately. We'll find the area of each face separately. Now, children, we are going to find the area of the front face. See, it's easy to visualize. If it's a, a physical class, then I'll have the object. And now also I can do it, I think, but I don't have anything with me right here. But I think it's quite easy for you to understand. So you can just, imagine a cuboid. The front face, which you can see here, this is the front face. This is the front face. This is the front face. Can you see the front face, children? Can you see the front face?
Yes, ma'am.
Now tell me the area of the front face. Front face is a rectangle. Front face is a rectangle. What is the area of that rectangle?
L into B, ma'am.
All of you think and keep your answer ready. I'll ask you. Don't say now. Area of the front face is my question. What is the area of the front face? You all know how the front face is. What's the area of the front face? Let me get an object. Meanwhile, you think. Are you able to see the object I have in my hand, children?
Yes, ma'am.
Okay. I want the area of this face, the front face. What's the area of the front face? It's a rectangle.
L into B square. L into height. I mean length into height.
Yeah. So see, Swati, you first said L into B. Now, when I showed the
Yes.
object, you are able to make out it's L into H, not L into B. So see, children, the area of the front face is length into height. Into height. Now, you should tell me if you're able to see the object clearly. This is the front face. This is the length. This is length. Into height. This is the breadth of the rectangle, but it is H. The value is H. L into H is the area of the front face. Similarly, the area of the back face, see, I'm showing you the back face. The area of the back face is also the same thing, L into H. The front face and the back face. See, for me, this is the front face. For you, looking from there, this is your front. This is the front face. You are looking from there. For you, this is the front face. That's okay. So, okay, for you, front face, back face. For you, this is the front face, this is the back face. What's the area of the front face? L into H. Back face also same thing. L into H. Understand all of you?
Yes, ma'am.
Now, the area of the top face and the bottom face will be the same. The area of the top face and the bottom face will be the same. What's the area of the top face? Area of the top face? L into
B.
B. This is B. L into B. Bottom face also. The area of the bottom face is also L into B. L into B. What's the area of the side face? The two side faces. See, the top and bottom face will have the same area. Top and bottom will have the same area. Front and back will have the same area. The side faces, the two side faces will have the same area. What's the area of the side face? The side face. What is this?
The length. 30 centimeters.
This is the length. This is the length. This is the length. What is this?
Breadth into height, ma'am.
Breadth into height. Side face. See here. See, this is the length. This is the length. This is the height. This is not the breadth. This is the height. See, this is which is the breadth. This is the length. This is the length. This is the breadth. And this is the height. The vertical things are height. Like this one is height. Vertical. All that which is vertical is height. Now I think Swati got it. Others, please try. Nandana, tell me what's the area of the front face? What's the area?
Into height.
Are you clear?
Yes, ma'am.
Length, see length into, this is the height, this is not breadth. L into H. What's the area of the back face, Nandana?
Length into breadth.
Same thing. Front face and back face, same thing. Length into height. Correct?
Yes,
okay. Nandana, what's the area of the side face? This one?
Length into breadth.
No, how is it length? This is only length. What is this? Can you see what I'm showing? This one. This one.
Length into
This is not length, darling. The front one. This one is length. This is length. What is this?
breadth
Breadth.
into
Breadth into
height.
height. Breadth into height is the area of the side face. What's the area of this
Front
side face?
and back side is length into height, ma'am. Side is breadth into height.
Breadth into height. Breadth into height. This one is also breadth into height. What's the area of the top face? This top face, this one. See here, L into B. The top face. Length into breadth.
Okay.
Bottom face also length into breadth.
Okay.
Now see the figure here, all of you. See this figure here and understand again. See here. This is the front face. I'm showing you the front face. This is the front face. You can see the length is L and the breadth is H. The breadth is H. So L into H is the area of the front face and the back face. Now, these are the two side faces, this one and this one. You can see here, breadth into height. The area of the side faces, see a breadth into height. This one also, breadth into height. And the top face, L into, this is B, this one is B, L into B. The top face is length into breadth. The bottom face is also length into breadth. Now, the CSA, the curved surface area of a cuboid, the curved surface area of a cuboid is the area of the four vertical faces. Four vertical faces. That is area of front face and back face, front face and back face, front face and back face, plus area of the two side faces. The two side faces. This is all just for us to understand, okay? The two side faces. Now, what's the area of the front and back face? Tell me. What's the area of the front and back face?
L into
L into
H.
L into H. So L into H. Front face and back face is also L into H. Plus side faces?
Ma'am, B into
H. B into H. Two faces. No, so again B into H. There are two side faces. B into H, B into H. Then the front face is L into H, L into H. Okay, so this is nothing but 2LH plus 2BH. So when you take out 2H common, 2H is common, you will get L plus B in the bracket. So 2H into L plus B is the formula to find the curved surface area of a cuboid. Square units. Please write down, children. Please write down.
Completed.
Okay, so this is about the curved surface area or the area of the four vertical faces of a cuboid. 2H into L plus B. Or you can write it like this also, 2 into L plus B into H. It's a product only, no? See, A into B into C, you can write A into C into B, or you can write B into A into C. It's a product, so you can change the order and write it. So you can also write this 2 into L plus B into H also. That's also the same thing, square units. So don't get confused. If your teacher says 2 into L plus B into H, don't get confused. It's the same thing. 2 into L plus B into H is the same as 2 into H into L plus B. Can I clear the screen?
Yes, ma'am.
Okay, we'll just understand one more and wind up the session for today. TSA of a cuboid. TSA of a cuboid is the area of four vertical faces plus area of top and bottom. Correct? Top face and bottom face. Total surface area of a cuboid is equal to area of the four vertical faces plus area of the top face plus the area of bottom face of the bottom face. So the area of the four vertical faces we just understood. Front face is L into H. Back face is also L into H. Plus the side faces B into H. The other side face B into H. What's the area of the top face? See, this is the four vertical faces. LB plus bottom face LB. See, I'll write it again if some of you didn't understand. The four vertical faces, what we just understood, four vertical faces. Okay, the front face L into H, back face L into H, side face B into H, another side face B into H. So four vertical faces. Top face L into B, bottom face L into B. So what is this? 2LH plus 2BH plus 2LB. 2LB. So I'll just rearrange this. 2LB plus 2BH plus 2LH. I'm just rearranging. Now 2 is common. So 2 of LB plus BH plus LH square units is the formula to find the total surface area of a cuboid. 2 of LB plus BH plus LH square units. Because when you take 2 common, then you'll get in the bracket LB plus BH plus LH. This is the formula to find the total surface area of a cuboid. Understood, children?
Yes, ma'am.
All right. Please write down. Done, children?
Yeah, ma'am, completed.
Yeah. All right, children. So that's it for today's session. Thank you so much. Good night.
Thank you, ma'am.
Thank you, children.
Okay,